In this video, we're going to solve an optimization problem using inverse trigonometric functions. In most cases, optimization involving inverse trigonometric functions deal with subtended angles. Okay, uh, Subtended angle is an angle formed by an object at a specific external point or viewpoint. So for example, if you're looking at a tree, imagine this is you are looking at a tree, right? So from your point of view, the tree makes a subtended angle, let's say angle theta. Let's try this example. A 5 feet high painting on a wall is positioned 4 feet above your eye level. How far from the wall should you stand in order to have the best view? So best view here means the best viewing angle. Okay, best viewing angle. Okay, and this means that we want to maximize the subtended angle made by the painting relative to your point of view. Okay, let's say this is your point of view, and let's say this is where the painting is placed. Okay, so according to the problem, it is positioned 4 feet above your eye level. This means that the lower edge, okay, is 4 feet above your eye level. If this is your eye level, then the lower edge of the painting is 4 feet above your eye level. Okay, so 4 feet. Also, the painting is 5 feet high. So, painting is 5 feet in height. Okay, from your point of view to the upper edge of the painting and to the lower edge of the painting, a subtended angle is formed. Let's call that angle theta. Okay, and then as you can see, we have two right triangles here. We have the bigger right triangle and the smaller right triangle here. So for the bigger right triangle, let's call this angle here, angle beta. Okay, and then for the smaller right triangle, let's call this angle here, angle alpha. Okay, now we are interested in angle beta here and angle alpha because it's easier to deal with right triangles compared to oblique triangles. If we have right triangles, we can easily formulate equations or expressions involving trigonometric functions. All right, the question is how far from the wall should you stand in order to have the best view? So we want to find this distance here. That will maximize angle theta. So the formula or the equation for finding angle theta is our primary equation. Okay, so required is x at maximum subtended angle or angle theta. Okay, so again, primary equation is the equation for finding theta. Okay, so what we want is to set up an equation that will allow us to find theta. So from this relationship of angle beta, angle alpha, and theta, we can see that theta is the difference between angle beta and angle alpha, right? Therefore, this is equal to beta minus alpha. Next step is to express this equation in terms of inverse trigonometric functions. Okay, so let's start with the bigger right triangle. So we have here angle beta for the bigger right triangle, right? Relative to angle beta, We have here x as the adjacent side, and then the opposite side is uh, the total length of this side, 5 plus 4, which is 9. Okay, therefore tangent, because we're dealing with opposite and adjacent side, so tangent of angle beta is equal to the opposite side, so this is 5 plus 4 in total, that's 9, divided by the adjacent side, which is x. Okay, and then isolating beta, we get arctangent of 9 over x. Then for the smaller right triangle, where this angle is angle alpha, so the same trigonometric function can be applied. We have opposite and then adjacent, so the same tangent of, in this case, angle alpha. So tangent of angle alpha equals, the opposite side is 4 feet, so plug in 4, adjacent side again is x. Okay, and then isolating alpha, apply inverse tangent both sides, so we get alpha equals arctangent of 4 over x. The next thing we need to do is plug in these equivalent expressions for beta and alpha to the equation of theta. Okay, in summary, we have the primary equation theta equals beta minus alpha, where beta is arctangent of 9 over x and alpha is arctangent of 4 over x. So let's plug in the equivalent expressions. Theta now is equal to arctangent of 9 over x minus arctangent of 4 over x. And then now we differentiate this equation with respect to x. So d theta dx equals, derivative of arctangent is in the form 1 over 1 plus u squared, where u for this first term is 9 over x. So u squared is 81 over x squared. And then derivative of 9 over x with respect to x is negative 9 over x squared. Okay, minus, so the same general formula for arctangent, 1 over 1 plus u squared. This time u is 4 over x. So we have 16 over x squared times the derivative of 4 over x with respect to x. That would be negative 4 over x squared. Okay. Next, equate this to 0 and then simplify the right-hand side of the equation. So take the LCD in the denominator, we have x squared. So x squared plus 81, numerator is 1. And then let's just copy this factor for now, 9 over x squared minus, same process, LCD. So x squared, we have here x squared plus 16, and then negative 4 over x squared. Okay. Simplifying further, you get 0 equals, so this can be written as x squared divided by x squared plus 81 times negative 9 over x squared minus, so the same process, we can transfer x squared to the numerator. So this x squared here, so that we get x squared over x squared plus 16 times negative 4 over x squared. We can cancel out x squared for both terms, right? So that we can rewrite this equation as negative 9 over x squared plus 81. Second term, so we have negative times negative, this becomes positive 4 over x squared plus 16. From here, we can take the LCD and then multiply both sides by the LCD, or we can transpose one of the terms first and then cross multiply. Okay, so let's say we transpose the first term. This is negative, so it becomes positive on the other side of the equation, equals 4 over x squared plus 16. Okay, and then cross multiply, we get 9 times x squared plus 9 times 16, that would be 144, equals 4 times x squared, so 4x squared, and then plus 4 times 81, that would be 324. So group together the x terms, group together the constant terms. So 9x squared minus 4x squared, we get 5x squared, equals 324 minus 144, that would be 180. Okay, then divide both sides by 5, so that we are left with x squared equals 180 divided by 5, that would be 36. Okay, and obviously it's a perfect square, so square root of 36, that would be plus minus 6, but we are only considering the positive value because we are talking about linear measurements. Okay, so x equals 6, the unit is feet. This is now how far you should stand from the painting so that you get the best viewing angle. Okay,